Hello everyone. Today we are going to discuss about electrostatics, and this will be the first lecture of the series of lecture that we are going to do on electrostatics. We will go through the very basics and concepts which will make you accustomed and make you ready for the engineering and medical entrance examinations like IIT JEE, AIEEE, AIPMT and many such. In order to study electrostatics, the word electrostatic itself means that it deals with charges which can be protons or electrons, that is positively charged or negatively charged particles, and objects which are standing still. The word statics means that the object is standing still. So we are going to study in this chapter basically all devices and properties of charges which are standing still. Let us see some of the properties of charges. Electric charge. The basic definition of electric charge is that charge is the property associated with matter due to which it produces and experiences electrical and magnetic effects. What do we mean by this? This is the intrinsic property of matter due to which the object produces either an electric field around it, or when the charged particle is in motion, it produces a magnetic field. Later in the chapter of magnetism, we will know that whenever there is a magnetic field, it means that there is an electron or a proton, that is a charged particle in motion, because always magnetic effect comes due to the motion of charged particles. In this chapter, although we are going to study about the electrical properties for static charges, that is charges which are stationary. The origin of electric charge. How does a body gets positively charged or negatively charged, and when does it remain neutral? As you can see, this is the neutral body. A body remains neutral when the number of protons in it is equal to the number of electrons in the body. For example, a normal object, even the pen which you are holding, is a neutral body. Now, how does a body become positively charged? It is to be noted that it's the electrons which are responsible for the charge of a body, because generally the positively charged protons cannot be taken out of the nucleus, or the nucleus as a whole doesn't move out of the object. Then what does move out of an object? The electrons, because the electrons are loosely, the valence electrons are loosely bound to the nucleus, and by external effects, maybe thermal or electric field or by friction, these charged particles can be taken out of the object, for which the number of electrons in the body becomes lesser than the number of protons, and for which the body becomes positively charged. And on the other hand, if excess electron is given to the body, if more number of electrons are given to the body, then the body in turn possesses a negative charge, because we know electrons have negative charge whereas protons have positive charge. So if electrons are taken out of a body, the body becomes positively charged. On the other hand, if electrons are given to a body, the body becomes negatively charged. This is how a body acquires charge. When the number of protons and the number of neutrons is equal, then the body is neutral. Now, as charge is always due to motion of electrons, it means that there is always a change in mass of the body. So when a body becomes negatively charged, it has gained some mass, and when a body becomes positively charged, it means that it has lost some mass. Now how much mass has it lost or gained? It should always be equal to n times the mass of one electron, where n is the number of electrons which is either lost or gained. So the mass of an electron is 9.1 into 10 to the power minus 31 kg, and if n electrons are given out by an object, then it loses n into 9.1 into 10 to the power minus 31 kg, and if it takes n number of electrons, then it gains n into 9.1 into 10 to the power minus 31 kg. Now there are basically two types of charges. One is the positive charge and the other is the negative charge. A object becomes positively charged if it has lost electrons, and a body becomes negatively charged if it has gained electrons. And like charges repel each other. For example, here the positive charge is repelled by the positive charge, the positive charge is repelled by the positive charge, whereas unlike charges attract each other. For example, here the negative charge is attracted by the positive charge. Again here the two negative charges are repelling each other. Now what is the SI unit of and what is the dimensional formula for charge? The SI unit is coulomb. There are some more units. The ESU or electrostatic unit, or it is also known as stat coulomb, which is in CGS, and the dimensional formula is Q is equals to AT, where A is for the dimension of current and T is for time, because we know current is equals to charge by time, or charge equals to current into time. So this is the dimensional formula for charge. Charge is not a basic unit in SI system. Now some properties of charge. Charge is transferable. When is it transferable? It is transferable when the electrons get transferred from one body to another. Charge is always associated with mass. So whenever a body has mass, then only charge exists. Charge is conserved. It means that you can neither create charge by yourself nor you can remove charge, but charge can be transferred from one form to another. You cannot destroy it, you cannot create it. Charge produces both electric field and magnetic field. When does a charge produce an electric field? A charge produces an electric field when it is standing still. These are the three cases which you need to know for your entrance examinations. That is, when a charge is standing still, it is producing electric field. When it is moving with a constant velocity v vector, it is producing both electric field and also magnetic field. In the chapter of magnetism, we will come to know that magnetism is always produced due to motion of electrons. Without any motion of electrons, no magnetic field is produced. Now when a charged particle moves with a non-uniform velocity, where the velocity is not constant, that is, either it is accelerating or it is deaccelerating, then it produces three things. It produces the electric field, the magnetic field, and it also radiates energy. Now some more properties. For a conductor of any kind which can conduct electricity very well, charges always reside on the surface of the conductor. For example, if you have a metallic ball, say a ball made up of copper, and you put some charge, q amount of charge, into the ball, into the metallic copper ball, all the charges which you have given to the ball will reside only on the surface of the metallic ball. It will not remain inside the material, that is nowhere inside the material, neither in the center or inside the material of the spherical ball of copper. There will be no charge. The charge will be present only on the surface of the conducting material, whether it is a ball or cube or anything. The charges will always remain on the surface. Charge leaks from sharp points. Whenever there is a sharp point, there is a leakage of charge. There is a most probable leakage of charge from sharp points. Even charge is most attracted also by the charged points. One more property, which is the quantization of charge. It is a very important phenomenon which tells that charge can take only values which are integral multiple of the charge of an electron. Now if I ask you that can there be any body having charge in fractions of the charge of an electron, you may say quarks. Quarks have charge 1/3 of electron, but physically they do not exist in nature, which means that they do not remain isolated. Physically they do not remain isolated in nature, which means that they always combine with other quarks to form heavier particles. So which charge does reside to the smallest level in nature? These are the protons and the electrons. So we cannot have a charge which will be fraction of the charge of an electron. We know that the charge of an electron is 1.6 into 10 to the power minus 19 coulomb. Now this is the minimum charge possible in nature. You cannot have half of 1.6 into 10 to the minus 19 coulomb or 2.5 of 1.6 into 10 to the minus 19 coulomb, because the electron is the smallest body which can possess charge, and whenever a object either gains charge, it gains in the number of electrons. So if 10 electrons are gained, then the charge acquired will be 10 into 10 to the power 10 into 1.6 into 10 to the power minus 19 coulomb, which will be a negative charge. And if 10 electrons are given out, then the charge will be 10 into 1.6 into 10 to the power minus 19 coulomb, which will be a positive charge. But you can never have half charge or 3/2 charge or 16.5 charge, nothing. We can have only multiples of charge of the lowest value 1.6 into 10 to the minus 19 coulomb, which is the charge of an electron or of a proton. Thank you.